ठीक है, यहाँ पे इसको अभी तुम इसको कर सकते हो। सर दो मैं अभी बुलाऊं।
Very good morning. A very good morning to all of you. We'll be starting in a few minutes, so please settle down. Smriti Tatpartakriya, Yashayete Shadgurastasya, Nasadhyamati Vartate. With this beautiful shlok, I would like to welcome Honorable Chief Guest, Shri H.B. Srivastava, guest speakers, Dr. Jitendra Sharma, Dr. Karthik Kumar, Mr. Abhishek Goyal, and all the audience present here today. Today, we all are gathered here to celebrate the National Technology Day. This day is observed in India to acknowledge the contribution of technology to the country's economic growth and how far India has come in its advanced scientific achievements. This day is a reminder to the citizens of India how our country has climbed its way up to be a potential superpower in the coming future. So, I would request Honorable Director Sir to welcome our esteemed guests and present them with the saplings.
Thank you.
Thank you, sir. Now, I would like to invite the Honorable Director of IIT Roper, Professor Rajiv Ahuja, to deliver the welcome speech and comments the event. Professor Rajiv Ahuja joined the Institute in April 2021. Before joining IT Roper as director, Professor Ahuja was professor at the Uppsala University in Sweden for 30 years. He is one of the most highly cited researchers in Sweden. His main area of interest is computational material science, with main focus on energy batteries, hydrogen storage, and production. He has established more than 1,000 scientific papers in peer reviewed journals with H index of 90, and the number of citations are approximately 38,000, out of which more than 100 are in high profile journals. He was recently elected as the Fellow of Royal Society Chemistry London APS Fellow by American Physical Society USA, and also appointed in the advisory board of Journal of Material Chemistry and Material Advances from Royal Society of Chemistry. He is associate editor of Nano Energy. Professor Ahuja has supervised 30 PhD students and more than 35 postdoctorals, and he regularly acts as a reviewer for the several international funding agencies, including NSF and DOE from the USA, NRC from Canada, and ESF from Estonia. So, sir, please start the event with your words.
Thank you very much. And it's my great pleasure to be here and share this dais with eminent people like Dr. Srivastav is here. And it's my great pleasure and my honor to welcome you here in IIT Ropar. And we just find out that we both belong to IIT Roorkee also. So we are sharing also our common thing and which hostel you are staying. We were talking like this in the morning. So it's my great pleasure, and also the people, especially you, coming from St. Govind, and we are really looking forward a collaboration with you also. And we know that Department of Mechanical Engineering is already working with you. So one can ask why we celebrate the Technology Day, and this is obvious. Maybe some of you already know that in 11th May 1998, and when India done the exploration, this nuclear explosion in Pokhran, so it was in 11th May 1998, and since from next year, 11th May 99, we celebrate this Technology Day to salute those people who work for this India's nuclear program and missile program. So this is also called as a Shakti Day. So this is why we celebrate the Technology Day in India, to just honor those scientists, engineers who work for the and India becoming one of the biggest or one part of the nuclear power countries. And so nobody can put eyes on us. So we are a very safe country now, and we can progress without any hindrance because of this people who deliver this, and that make us one of the nuclear power countries. Another occasion also, because since Srivastavji here from DRDO, and on that day also the DRDO successfully tested this missile Trishul. So that is also one of the reasons to commemorate the 11th of May. So technology is an important part nowadays in our life. And without technology, we cannot be Atmanirbhar Bharat, what our Prime Minister he always talk. So if you want to be a self-reliant or be a leader in the technology, we have to do some certain changes, and we have to think in India in a different point of view. So as you are here, you are the youngest mind of India. And we always say that India is a country of the young people. And if you look at the average age of the young India is only below 30 years or so. India will be the leader. India in next 10 years will be the biggest skilled manpower provided country in the whole world. So all countries are looking towards India now. So we have the potential, and we can provide a skilled technology manpower around the world. So India has a very bright and very bright future. When we talk about IITs, and maybe you know that Right now we have 23 IITs in India. When IITs was set up in the beginning of 50s, just after the independence, the mandate was on the IITs was at that time also, there were many engineering college even that time. So it was not that before IIT we don't have engineering college. And one example is the Roorkee Thompson College of Engineering, and where we are celebrating now 175 years of the establishment of the Thompson College of Engineering, which now known as IIT Roorkee. And if you go nearby in Chandigarh, so if you go to Punjab Engineering College, it was there, and they are celebrating this year 100 years. So there's no IIT which is 100 years old. So the oldest IIT is a Kharagpur from 51, and you can see how old is that. It's maybe you can say 70 years old only. But you can see that if you look at the Indian perspective or the world perspective, nobody know any other institution outside India or in India than IITs. So IITs are now a brand. And if you go to any country, you go to United Nations, if you say that I am from IIT, you will get a special respect. Because IITs have created that kind of service to the other countries. I can tell you, US economy is run by IITians. You can look at the big company CEO, they are all from IITs. So IIT has participated in the technological growth of India also. And when IITs was set up, at that time IITs was set up for the science-based engineering education. That was a mandate of setting up the IITs. We remember that when IIT Kanpur was set up in collaboration with the US, and US only want that IIT Kanpur should only produce engineers. They should not do any research. But at that time, the faculty opposed it. They say, we came to IIT so we can do both research and teaching. That's why we came. Otherwise, we can go back to university. So all the faculty members at that time, they threatened that IIT should do the research. And that's why now IITs are known also when we come in the technological research area. So technology is the important part, but when IITs was set up, it was set up as science-based engineering education. So science was a key component. Nowadays, we are all talking about, if you look at, if you hear any speeches from our Prime Minister Modi ji, and he talk about entrepreneurship, he talk about intellectual property rights, he talk about patents, he talk about innovation. And I can tell you that if you want to be an innovative country, and India can be only succeed if we are an innovative country. Without innovation, we cannot do anything. Otherwise, we are doing same thing like other countries are doing, we are following that. But we cannot be the leader. So what is necessary to become innovative? So we should have a very strong basis in the basic sciences. And this basic science basis, strong basis should already started from the schools level. We are not talking that you come to IIT, then you make your basic strong. Starting from 12th standard, you should make your basic very strong. Don't cram the things. Try to understand it. Once you understand the basic, you will be yourself innovative. Innovation doesn't come from outside, it comes from your inside. When it comes, when you are strong in basic, you can think about it, not cram the thing. So I can say that basics are the mother of innovation. So, and any country or any institute can be only successful with only two mantras. One is called innovation and other is collaboration. So we need to learn, we have to work in a collaborative mode, and we have to work together as a team. We cannot do anything if we are doing something individual. So we have to be working together. And here, so many young people are sitting here. And can you tell me which was the last year when India got a Nobel Prize? Can you tell me? I can tell you otherwise. The last Nobel Prize we have got in science or technology, whatever we talk, that was by Professor C.V. Raman. In 40s, we are talking about. Since that, we cannot produce any of those kind of scientists of that level who can get a Nobel Prize for India. Why? And I can tell you that if you look at around, and then if I ask you who will get next year Nobel Prize, everybody will say that it will be somebody from US or from Europe or maybe from Japan. There is no other country you can think about, because why not? Why not you can think about India? Because we have to make, if you look at the pre-independent time, or just even after independence time, India was very strong in basic sciences. And you can think about, if you know, the famous people, you can talk about Schrödinger or Einstein. That time they were offered a faculty position in University of Allahabad. So at that time, Allahabad University was so strong in basic science. So those people, those big people which you see that who got the Nobel Prize, they want to come to India and work in India. So, but we lose this basic science concept. So we have to make basic science strong. When our basic will be strong, our technology will be strong also. So they go one to one. You cannot be a technology advanced country without a basic science strong. So I can tell you, you can think about China or South Korea. So they are very technologically advanced countries. Since I come from Sweden, I tell you right now, they will never get a Nobel Prize because their basic is zero. So they are not putting emphasis on the basic side. So they are just is a production factory. So this is what they are doing. So we have to make our strong basic. Don't cram the thing and try to understand the thing and try to be involved in some kind of research. And that's what we want also in our BTech curricula also. They go for internship outside. They want to go in a company, that's good enough, but they should also spend some time in the labs where they can do some kind of basic or some kind of research. They can go within IITs, different IITs or DRDO's labs or BRC or TFR or different kind of institution, or they can go for summer internship even outside for 2 months and spend some time and develop some kind of research culture. And because if you want to work in industry, if industry, what our industry is right now doing, we are not making ourselves, we are just copying somewhere else, or these foreign companies are coming in India and they are making in India. But is there anything what we can make ourselves? So we have to make our research and development very strong. So we have to work together with industry, and we have to do what industry want from us. Because in Indian system, academia and industry work very separately. So we have to learn how we can bridge this gap and we can put industry and academia on the same platform. So universities or institutions like IITs, they should work what industry want. It's not like that what I want. So only that way we can be successful and we can have our own technology. We don't have to rely on other countries. We should be the leader. We should not be the followers. So we have to develop. Right now, we have a problem in country in the semiconductor industry. We want to make a lot of electronics thing, but we cannot make the chips and all those things or sensors for small thing. And when we talk about EV vehicles, we have to develop our own batteries, which we can provide. Because when we talk about electrical vehicle, so how we can do that? India is a big market. So if we want to go for EV, we have to develop different energy storage sources and we have to make our own. We cannot just use lithium-ion batteries and importing from China. So we have to be self-reliant, and we have to develop a technology which can be directly transferred to the industry. So we have to work on those areas. And the semiconductor is one of the areas where India needs a lot of efforts, not only in terms of the research, but we have to make an infrastructure here also where we can develop all those things. And with that, I will not take much time. And as Dr. Srivastav is here, I will leave to him. He's coming from the DRDO. He has a lot of experience. He can share with his experience with you. And this Technology Day, some of you have came from outside of this IIT Ropar, and I want to give you a message that in your own institute also, you should celebrate Technology Day, and you should do a big scientific activities and where you can share with your research, with your colleagues, with your friends, and that will be a way how we can lead and how we can be a Atmanirbhar country when it comes to the technology. And with that, I will stop here. And I welcome all of you again in IIT Ropar campus who have came from outside. And I hope this day will be full of lot of things and events. And maybe it can help you to build in your career, or somewhere it will help you this interaction, and you can start a new collaboration with IIT Ropar. Thank you very much.
Thank you, sir, for the welcome speech. Now I would like to invite Dr. Naveen Kumar, Dean of Research and Development, to throw some light on the technological initiatives and developments at IIT Ropar.
Very good morning to all of you. I first of all thank our guest, Srivastavji. Thank you, sir, for coming here. In fact, our director told me that we should celebrate the Technology Day at, I think, 4th or 5th May. Then I say it's very difficult to invite the guests because with such a short notice, then we have contacted you, sir, and you are kind so that you came here in person. Thank you, sir. I also thank Dr. Karthik coming from St. Govind Research Center, Chennai. You are taking so much efforts to come in person. Thank you, sir. We have other two guests also, Dr. Jitendra, CEO, MD of AMTZ. He is also online. And I also thank Mr. Abhishek Goyal, Vice President of Infosys. Thank you all. And also, I also welcome this young generation, which is coming far away from Kapurthala, Hoshiarpur. You have traveled so much distance to come here. I welcome you all, and our students, our faculty members. I welcome you all here. Thank you for coming here. So from this Technology Day, you see, from Buddha Smile to Operation Shakti, we have reached a milestone in nuclear energy. Not only in nuclear energy, in outer space also, you see, we have reached to Moon, we have reached to Mars, to the other planet also. So it's a big achievement for Indian scientists. You see, we are Jal, Thal, Vayu, we are capturing all and try to see that we can explore more potential in terms of science and technology there. Coming back to here in Punjab, we have so many eminent personalities in the field of science and technology. Our Satish Dhawan was from here. He was the director of ISC Bangalore. We have one building name with him. In fact, our Department of Mechanical Engineering building is named with the Dr. Satish Dhawan building. We have eminent Professor Chopra, K.L. Chopra, ex-director of IIT Kharagpur, which he was from Punjab. We have so many eminent persons. Professor Khurana, Nobel Prize winner, was from Punjab. Professor Vimal Sahani, who is with whom we have the institute in Fossil Research Institute in Lucknow. So we have so many eminent persons from our Punjab, Sadda Punjab. So it is honor for us, and IIT Ropar has contributed immensely in the development of technology and various initiatives. I have a short presentation. If you can run that presentation, please. So I will shortly showcase what things we have achieved within this shortest span of 13, 14 years of our IIT, which come up in 2008. And within this short period, we have so much achievement. So here I will talk about some of the development, some of the figures in front of you. Yes. Yes, so we have, if we talk about these research projects, we have about 333 research projects within this span of 13 years. So you can see that how many projects we are getting it from the different funding agencies, primarily from the government agencies. If we talk about the total sanction amount, we have about 336 crore of funds with us so far. And with respect to the consultancy, which our faculty members get for different technological developments, we have about 280 projects with us so far. And if we talk about the sanction amounts, it is about 70.8 crores of worth of funds we have from the consultancy from different industries. Nevertheless, we have so many departments. Their objectives have different objectives, like computer science department. We have a very strong team. They work in the computer vision, computer architect network, AI, ML, computer and data system, and so many agriculture-based applications. If we talk about the mechanical departments, we have major areas in additive manufacturing, biomechanics, composite materials, energy efficiency and sustainability, intelligent mechanical system, heat and mass transfer. Those are the core areas, major areas, but other areas also are there. If we talk about the electrical engineering department, the power electronics, high voltage, wireless communications, computer vision and AI, and integrated circuit design, some of the areas which our faculty members work, our students do a lot of work in those areas. Our chemistry departments also contributing a lot. They have very good publication record. So they are working in the energy, healthcare, sensor, medicinal chemistry, functional materials. If we talk about the chemical engineering departments, they have the specialist in the multi-scale modeling, soft metal engineering, transport phenomena, thermodynamics, energy environment, catalyst and reaction engineering. In the physics department, the condensed matter physics, the electronic structures, the gravity and string, some of the fundamentals they also study and have a lot of research in those areas. Light matter interactions, nuclear and particle physics. A lot of achievements we get. I will give you some of the glimpses very shortly. So we have this one project in the agriculture and water technology areas, which is funded from the Department of Science and Technology. It's this project is worth of 110 crores. Dr. Pushpendra is leading this project. So this is providing a lot of initiative, state-of-art initiative in the agriculture and water technology areas. Some of the areas are listed here. So, and a lot of startups, a lot of companies are supporting this, our center. Then our faculty members have a lot of patents, a lot of initiative like FakeBuster. Dr. Andhra is working in this area. Like UV Safe in the during the COVID time, we have developed this system which is used by a lot of five-star hotel. In fact, in IPL it is used. Then we have this doffing station to safety of the healthcare workers, where the negative pressure is get generated. Then we have this portable flue gas and laser cum air quality monitoring system, which is developed by our electrical department faculty members. We have this coating, state-of-art coating system in our IIT. So a lot of coating research. One of the faculty member, Professor Rapid, is working in this area. G1 Vayu, which is the which is using the even the very small amount of the oxygen, so that oxygen should not be wasted. So those are the initiatives which were taking some of the glimpse of initiatives. There are so many I cannot cover within this fixed time frame. So these are some of the initiatives. With this, I will thank you. But sir, you have said the Nobel Prizes we are waiting. I think this new generation, new fossil is here. So I'm sure very soon we'll have some of the very, not only the Nobel Prize, but we will have the great in the technology area. Thank you once.
Thank you, sir. Now, I would like to introduce our chief guest for the day, Sri H.P. Srivastava, Director General of Technology Management and System Analysis and Modeling at DRDO. Prior to taking over as Director General, he was the Director of Medtech, New Delhi, where he was spearheading various technology and product development initiatives in the area of high-power laser sources, laser spectroscopy, and laser countermeasures. He was the Director of Electronics and Computer Science at DRDO headquarters during the year 2013 and 14. He was also the Group Director of the Fire Control Systems in IRDE. He has worked extensively on stabilization of line of sight of various electro-optical payloads, including direct wing optics, CCD cameras, laser rangefinders, laser seekers, and thermal imaging cameras. An alumnus of IIT Roorkee and IIT Kanpur, he has authored and co-authored many technical papers in various national and international referred journals and seminar proceedings. He has co-edited a monograph on night vision and electro-optics technology review. He is also a life member of Optical Society of India and Instrument Society of India. He is a recipient of DRDO Group Technology Award and Laboratory Group Technology Award. So now I would like to welcome sir with a big round of applause.
Welcome.
So good morning to all of you. Professor Rajiv, Professor Naveen, my co-speakers, faculty members of IIT Ropar, the fellows, research fellows, the students of IIT Ropar and all the nearby institutions who have come here. First of all, congratulations to all of you. This particular day is not meant for any particular organization. It is to remind all of us that if we have the will, we can do it. And the country demonstrated this on 11th May 1998, when Buddha smiled, as was very aptly told by Professor Naveen. And Buddha smiled not because he wanted to smile. He smiled because all of us put our efforts together. And I always keep on telling, Professor Rajiv also mentioned about it, Sahyog se Shrestha. If we all collaborate together, we can do whatever we want to do, and whatever we need to achieve, we can do with collaboration. So many organizations work together. If you all recall, in 1974 itself, we had the first nuclear explosion, and we demonstrated that we can do it. But 1998 was a game-changing year, in the sense that we demonstrated that we can make devices out of the science. We can J.C. Bose, Jagdish Bose, S.N. Bose. You can take the number of names, Kalam, Kothari. We must salute, because they put the road in such a way that we are able to travel, and we are able to travel at the rate that is required by our country. Having said that, it is also, can go to the next one. Having said that, these goals are not very small goals, and if we are focusing on very low-hanging fruits,
that doesn't give us any benefit, that doesn't, we don't get recognized by focusing on the very short or very short-term goals or very low-hanging fruits. So we must always aim for long-term goals, and we can have the short-term goals in between, but short-term milestones in between, but our goal has to be very high. Then only we can progress to the level where we want to progress. Previous slide. When we talk of defense, many of you must not be knowing actually how this whole ecosystem of defense R&D is there in the country. Because the moment you say defense, you can always take refuge in secrecy. And there are certain things which are need to know basis. Definitely, there is no doubt in that. But there are so many things which are open to the world, and we have the system in place where we work with a lot of academia, and the industry, and various laboratories, various scientific organizations in the country. So I thought, let me just introduce you what is the defense R&D ecosystem of the country. In the Government of India, Ministry of Defense, there is a department called Department of Defense R&D. What you see in the, do I have the pointer? Yeah. So this is the Department of Defense R&D, which is headed by a secretary who is himself also a scientist and who also heads DRDO. And the ones that you see in yellow color, these are, yeah. So the blocks that you see in yellow color, these are some of the departments that are headed by him under the Department of Defense R&D. All of you are aware of BrahMos probably. There is a family of BrahMos missiles that has been developed, and also some of them have been exported. That organization. We have a university under Ministry of Defense, which is known as DIAT, Defense Institute of Armament Technology. It's a deemed to be university in Pune. We have an organization called ADA, that is Aeronautical Development Agency. Similarly, there is an agency I have not listed here, which is doing work for submarine. And like that, there are some other organizations which we cannot talk about openly. So these are all headed by Secretary Defense R&D, but the major department that is headed by him is the DRDO, because that is the organization from where the technologies are coming out. And other organizations are mostly users of those technologies. Now, we are having we have divided the technologies, defense technologies, into 7 technology clusters headed by what you see in green here. They are headed by Director General each. Electronics, the aeronautics. When I say electronics, it's the spectrum. It could be the communication, it could be the radars, it could also be the electro-optics. Then life sciences, the material sciences, naval systems, microelectronic devices, and whatever all are shown in the green color. And on the right side, you see there are corporate functions, which are, of course, 2 are major corporate functions. One are the human resources development and resources and management. We have a very strong collaboration with our industry partners and also with our users, which are mainly 3 services and also some police forces, armed police forces. But then we also have 2 technical activities at headquarters, which is systems analysis and modeling and the technology management. The systems analysis and modeling is actually does the modeling and analysis of the weapon systems being introduced into the services and how they are going to be effective against the adversary with respect to the strengths that they have. And also, if we can we do a different kind of deployment at different kind of places so that our strength, our punching power becomes more. That is the kind of analysis is done and given to the services users. The technology management that is the agency where we interact with academia and small industry startups and the MSMEs, and we take the technology. We are focusing in TM and the technology management. We are focusing on the technologies which are 10 to 15 years away from us. Whereas in the clusters that you see in green color, they are focusing on today's requirements how to fulfill those today's requirements in association with industry and academia. Whereas technology management is focusing at the technology that is required by us 10 to 15 years from now. And we also have, it will be interesting for many of you to know that we have 5 young scientist laboratories, people who are less than 35 years of age. Even the director is less than 35 years, and he has full powers of whatever procurements other directors can do, who are generally about 50 years and more. He can get into whatever collaboration that he wants with academia, industry, wherever, and he can choose his own methods to conduct the research, all those kind of things. He's fully empowered. 5 such laboratories exist, and I will give you a little more in details. So we are about 50 laboratories and work centers. Budget is about 20,000 crore, which comes to about 6% of the defense budget. About 20,000 people, out of which about 7,000 are scientists. And you will be happy to know that the Defense Acquisition Council cleared equipment worth more than 3 lakh crore have been introduced into the services, which have the origin from DRDO technologies. Of course, they are not manufactured by DRDO, they are manufactured by industry, both private sector as well as in public sector, foreign sectors as well earlier. We work in more or less everything, every area from space to underwater, from life sciences to destroying the life, all areas that are required for defending our country. They are, we work on them, the missiles, fighter aircrafts, tanks, artillery guns, torpedoes, UAVs, you name communication systems, support systems, whatever you name, we are some of the laboratory or more than one laboratory may be working in that particular area. And when I say laboratory, it is not only that laboratory, we also collaborate very extensively with our industry as well as the academic partners. So they're all included when I say the industry, the laboratory. These are the organizations who are our users: Indian Army, Air Force, and the Navy, primarily these 3. And the offshoots of the technologies developed for these particular organizations, they go to the police forces because the kind of performance required is not that much that the armed forces will require. So the cheaper part of it, or the smaller or the lower variant of the equipment going to the Army, Navy, Air Force, that also goes to police forces or the Indian Coast Guard and things like that. And when I say police forces, it's primarily the central police forces, because state police forces require even lower amount of technology. So they are generally given by our industry themselves. And once in a while, they will ask help from us, and that we will be providing. So the areas, if you look at the first row, weapon systems, platforms, and sensors, I think there's wrongly written, it should have been sensors. We need to have technologies that will sense the threat. And we need to have the weapon systems and platforms on which our sensors and weapons will be employed to neutralize that threat. So whatever has to be done, that all is being done within the system. And of course, the newer age technologies like artificial intelligence, cybersecurity, robotics, all these things, newer materials, newer devices, intelligence, and those kind of things, they all need to be built into those systems. And this is not the exhaustive list because of the space is limited. So I put only few of them. So all these new age technologies need to be put into these weapons, sensors, and platforms, which will enhance the performance of soldier. And they will be able to do much better than what they're able to do today, and also better than our adversary. So that is the prime motto of putting all these technologies. We are all proud, and I think as a country, we must take pride that we are one of the few countries, one of the very, very few limited number of countries you can count on your one hand finger, who have the capability to neutralize a satellite in orbit. And this capability is required because tomorrow the war may require it. We need to defend our country, and that defense has to happen not only on land or in sea or in air, it also has to be in the space. So all the things, and also cyberspace. So all these capabilities have been built, and this is an event of equal significance as that happened on 11th May. So I thought I should put that also across to you. This is something which not many people can do in the world. If you look at the weapon systems, today we are capable of developing any kind of missile that is required by our country or for the countries which are friendly to us. So we can make ballistic missiles, whether they are long range or small range, intercontinental missiles, intermediate range ballistic missiles, surface to air missiles, air to surface missiles, surface to surface missiles, underwater to air missiles, subsonic missiles, supersonic missiles, hypersonic vehicles, everything, all technologies that are required for missile area are within control of our country. We can very proudly say that we are Atmanirbhar, self-sufficient in this particular technology. And as we defend in sky, we also need to defend on underwater. And we have all the kind of technologies that go into making torpedoes or defending our ships and submarines from torpedoes. And similarly, on the ground, we have, let me also show you this particular one. This gun has been developed by one of our laboratories in Pune in association with two private companies, Tata and Bharat Forge. And this is the gun that is having longest range in the world. Longest range in the world has been evaluated at the most demanding locations of our country. The high altitude, very, very low temperatures, the deserts, when the temperature is very high, all kinds of evaluations it has gone through, and it is going to get inducted very soon. We have a very long-range rockets available with us, precision rockets in the name of Pinaka, the next one that you see. And they are able to target the adversary at 100 kilometers plus. We have demonstrated hypersonic missile technology, hypersonic vehicle technology, glide technology. Our missile that we sent in the sky that was there for about 20 seconds. So all the kind of technologies and of course various kinds of torpedoes that I mentioned here earlier, they are all available here. Similarly, in the area of platforms, we are one of the 5 or 6 countries which make the battle tank. And we have the capability to make battle tanks which are very, very light and which are also heavy battle tanks. Each one of them will have their own utility. Arjun, for example, already some 124 numbers. 124 numbers are already in service in 2 regiments. 124 more have been ordered. And these are going to get inducted in larger numbers very soon. The web that you see here, the second one, it's a wheeled vehicle. This also is totally indigenous in association with the industry. Arjun also is in association with the industry. So we have the mastery over the tracked vehicles as well as on the wheeled vehicles. And of course, again, all of them have been going through the trials in deserts and all the places that are required in high temperature, low temperature and all that. We are able to, you may be surprised to know that T-90 tank, which is imported from Russia and of course now being manufactured at HVF in Audi, Chennai, and Arjun also being manufactured by the same company. Both of them have been running together, they have been firing together, and Arjun has been giving a performance which is acceptable and which is much better than what an imported system can give, and which is all indigenously developed tank. When I say indigenously developed tank, there are certain, I must also say that there are certain assemblies which are reported at the moment, which have been indigenized and that will get into the production very soon. But the design part is totally indigenous. What we want, we could not make them in the country because of some reason or the other. That could be one issue, but the design is totally indigenous for all of the systems that I've been showing you. Missiles are having about 85 to 90% indigenous content. The tank is having about 55 to 60% indigenous content. And similarly, all the bridges, and today people are also talking of Heliborn Bridges. That is, the helicopter will take those bridges and they will be deployed where a 70-ton tank can move on those bridges. That kind of technologies are existing. And similarly, the UAVs, the Rustams, Rustam 1, Rustam 2, Panchi, and so many other things. Some of these, on the right side, top right, you see the AEW&C. This is You fly in the air, and from the air, you can find out what your adversary is doing, maybe 200, 300 kilometers away from you. So that situation awareness and the defense that you can do against the airborne targets, that decisions can be taken. So these are all our own indigenous capability that have been developed over the years. Some of them have also participated in the action in various places. Now, one of our weakness as a country is the propulsion system. We don't make propulsion system in the country. And this is where the percentage of indigenization reduces when we talk of airborne platforms especially. There's a lot of thrust being given in last few years, and a lot of people, both in academia and industry, along with various DRDO, ISRO labs, are working together. What we require today is about 110 kilonewton engine. And what today our capability as a country is about 35, 40, 50 kilonewton kind of thing. So there's a huge gap, and I'm sure that if we all work together, we will be able to solve that problem soon. Like missiles, we are also self-sufficient in two other areas, the sensors, in fact, three areas, the sensors, whether they are in the electromagnetic spectrum, radars, all kind of radars, 2D, 3D, small range, long range, imaging, SAR, AESA, that is electronically scanned radars. All those technologies are within our control. Now, in fact, there is no need for us to import any of radars. That is the kind of capability we have. And also the transmitter receiver modules that go into making the radars, all those technologies, even the industry has got today. So we need not actually do the research in academia. Okay, we may have to do research in the newer devices, but the standard devices, we need not actually work in the academia or in DRDO labs. The industry is able to take care. So that is the kind of advancement that has taken place in the capability of the country. Some of these radars have also been exported. Similarly, the sonars, underwater sensing, we are again self-sufficient. We make sonars for ships, we make sonars for submarines. That I say we only develop, DRDO only develops, the industry makes. And as of today, mostly industry means BEL, but very soon we are going to have a number of private industry also doing the same thing, manufacturing this, because only one particular production agency is not able to make the ends meet for export as well as for our indigenous consumption. So various kinds of sonars have been developed, and again, we are self-sufficient in this technology. In surveillance systems, again, the electro-optic sensors, for example, what you see here, and the laser sensors. So we have lidars that can actually sense the properties of clouds. And when I say cloud, it could be various types of clouds. It could be rain-bearing clouds that normally IMD, meteorological department, would require. But we also have capability to sense the biological cloud. If there is a biological threat tomorrow, we will be able to sense that at standoff distances. And similarly of chemical threats that we can sense at various distances. We also have the capability to deeply look into the enemy territory and get the information in the visual domain, in the electro-optics domain, and also in IR, infrared, whether it is short wave, medium wave, or long wave infrared. So we have all the capabilities available, and all these equipment, whatever you are seeing here, they have all being made by the industry now. The explosives can also be detected from longer standoff distances. In a very recent past, about 6 months, within 6 months, I think it was in October, 4th of October or so, this particular technology was transferred to two industries. When the events like important events where the VIPs or VVIPs participate publicly, there is always a threat of drones. Those drones can bring the bombs or explosives or whatever. So they need to be tackled at the distance which is more than what they can actually engage. So we have the technology by which we can actually burn that drone and using the lasers. So this technology has been very recently transferred to 3 or 4 industries, and they are making these in good numbers now. Now, this is a short distance, as I said, using the lasers, neutralizing the target at maybe 1 kilometer or 1.5 kilometers or half a kilometer. But today, and you might have read the newspaper reports or TV reports, that good amount of ranges have been achieved by countries like US and Israel, and using the high power lasers. Our country also, we have the technology. We don't have the full technology yet. We are still working on that, but we have good amount of understanding and the knowledge as to how it can be done. And there is a laboratory focused on that kind of activity with all the indigenous things that they are trying to build that particular system. Similarly, in the microwave region as well. We have various types of activities going on for thermal imaging, thermal images that can go on aircraft, that can go on battle tanks, that can go in missile seekers and things like that. And similarly, communication systems, various types, whether they are software-defined radios or troposcatter or things like that, SATCOM, everything, all those technologies are now indigenously available. And when we say the measures as to how to neutralize the enemy, we also need to have countermeasures. If the enemy attacks, what to do? So if he is trying to take away our knowledge through the communication systems or through electro-optical sensors or through radars, etc., we also have the countermeasures developed within the system, within the country. So whether EW systems for ground-based requirements or ship-based or airborne or things like spaceborne, all those kind of things are now with those technologies are available. Similarly, bombs, various kind of bombs, and the projectiles, gun projectiles, everything, those kind of technologies are also available, being produced by some of our country. For low intensity conflict, where man-to-man fight, and for infantry also, we require small arms. And those small arms, various types, whether they are grenade launchers or close quarter carbine or chili grenade for the Kashmir kind of situation, where the terrorists are trying to attack and all. All those kind of things are being made in the country. And let me also inform you that your neighbors in Chandigarh, TBRL, are also involved in many of these activities. I forgot to mention that 1998 Pokhran, our activity, TBRL was also there. And you do have a scientist today, I don't want to name him for his own security, safety, etc. You do have a scientist who is living today in Chandigarh, who participated in 1998, not only physical, but also technologically contributed a lot in that particular activity. So Punjab has actually given that support as well in the Pokhran. And various kind of things, you can jam the communication, you can send your robotic vehicle to get whatever is required to be done at some places, you can send the UAV, you can send the drone, all those kind of things are available in the country. One of the points that I think Professor Rajiv discussed was about the microelectronic devices. So we do have certain programs, and I am happy to inform you that there are various types of ICs that have been developed required by Space, Department of Space, and they have been used by them in various space missions. We have a society called STAR-C in that makes those kind of MEMS devices, and those have been utilized in some of the places. Now, one of the things that you may or may not be aware, especially the students, that there are these active devices which may have content that can be taken away. You may not be aware of what somebody is trying to take the information from your system and then trying to take to the OEM's locations. So in defense systems, we cannot and we should not use such kind of devices. So some of these devices need to be indigenized, especially for the mission critical items, and they need to be used that we need to use those kind of devices only. So all the hardware and software is required, they are all being done in the country by some of our labs and some of the industries that work with us. Similarly, for the nuclear, biological, and chemical defense, a lot of work is happening. We have decontamination systems, protection systems, detection systems available. And if there are small ranges made, tomorrow we need longer ranges, higher intensity detections or protections. So all those kind of research is happening in the country. Similarly, the life support, whether you are in the submarine or in the aircraft, all the kind of technologies required, whether telemedicine or oxygen enrichment systems. And I am happy to inform you that what we did for LCA, the oxygen concentrator for the pilot, that technology got multiplied during the COVID times. And today you have close to 1,500 oxygen plants of that particular design working in the whole of the country. And soldier support technologies, again, clothing, protection systems, reconnaissance systems, weapons, accessories, things like that, communication. Now, materials are something which actually, they are the backbone of anything. Unless we have good material, the required properties with less weight, we will not be able to meet the requirement of our armed forces. So this is an area where continuous research is required. We have done some work, but we cannot stop there. So we have to keep working on getting better properties with lower weight. And that is how the research is going on in various places, multiple labs of DRDO and various academic organizations. So for doing all this, you require actually a very advanced kind of infrastructure. And we have various kinds of facilities, some of them I'm showing here. And these are all available to academic institutions as well as industry for them to utilize on nominal payment basis. With nominal payment, because then the seriousness comes. Otherwise, if it is freely available, people will not be serious for their own research as well. So whether it is wind tunnel or floating test range or aeronautical test range or open test range for testing various kind of missiles or communication systems. All those kind of things are available. We have the highest, and it is in Guinness Book of Records, the highest research lab in terms of altitude in Chandla. So everything, the low temperature research, the high temperature research, everything can be done in the country. For very, very less things we need to go out, but all these things are available. And they are available to everyone, not only to DRDO, but also to everyone. As I said, new age technologies like artificial intelligence, and I was happy to see that the thrust is here in IIT Ropar as well. We need to put artificial intelligence in all the platforms that we develop, or all the weapon systems that we have. And they can be for different things. In fact, imagination is only the limit to put the artificial intelligence. They could be for better exploitation of the images. They could be for better exploitation of the information that we have, or it could be for better engagement of the adversary that we are looking at. It could be for alerting the people as to the coming threat. So various kind of things can be actually addressed by artificial intelligence. And we have a young scientist lab working on this. Apart from the mandate to all the laboratories that whatever the, systems that they are developing, they must introduce the AI component in that. Again, the electromagnetic railgun. This is also a technology where very high level of energy is required. So along with IIT Delhi and one of our laboratories in Pune, they have done this work and they have accelerated up to, let's say, about 6 Mach speed. But this is only a quarter kg kind of a projectile. But what is the requirement is about 100 kg, 1 kg. 1 kg kind of penetrator. If some armor has to be penetrated, it has to be the projectile has to be about 1 kg. So 1 kg projectile going at 6 Mach speed, that is where we need to reach. A lot of research is going on in the academy as well as in the laboratories. We are also participating in Gaganyaan, and you see 8 or 9 equipment that are being developed, and there's a very strong collaboration between ISRO and DRDO to do all these activities for the Gaganyaan. Similarly, for the UAVs, various kind of UAVs have been developed. Mostly unmanned. What has not been done today is the combat UAVs. That is where our focus is shifting now to combat UAVs. Quantum technologies also, we have young scientist laboratory working, and in all areas of quantum, whether they are sensors or computing, communication, radars, navigation, everywhere we are having some activity going on. I must also inform you that we are one of the few countries, and in fact, after our demonstration, the news came from China. We demonstrated QKD, quantum key distribution, on existing fiber network between Prayagraj and Vindhyachal, 110 kilometers, about 110 kilometers, successfully done using 2 protocols. Whereas China, after about a month or so, declared that they have done 30 kilometers, then repeater, another 30 kilometers, then another repeater, and 30 kilometers. So like that, 100 kilometers they have done. So we are at par with anybody in the world today as far as this quantum key distribution part is concerned. But of course, there is still a lot to go. Just 100 kilometers is not enough. We should be able to transmit the key using the satellite, and we must be able to transmit that key after getting from satellite to anywhere in the country. So that is where the work is going on. Similarly for the sensing, etc. Like that, cognitive technologies are also very important. We must be able to sense what is going on around us, and then take the informed decision. So these again are very, very important technologies as far as the defense and security are concerned. And we have another young scientist laboratory working on this particular technology. They are making cognitive radar and cognitive communication systems, and all those kind of things are happening in that particular laboratory. Robotics, a lot of work has been done, but a lot is yet to be done. We want to have a robotic soldier. He should be able to find out his own way of fighting the enemy. If we can get that, it will be good for us. We can save the human lives. So that is where the research is going on. Robotic mule, robotic soldiers, exoskeleton. These are the activities that are being pursued at the moment. Now, having told you what all has been done and what all is being done, I must also tell you what are the challenges, because that is the topic of I said that I would like to tell you the challenges and the opportunities. So the challenges in defense ecosystem are actually many. They are not limited to this, there are many more. The first and foremost is that your same equipment must perform in high altitude and also in deserts. So at high altitude, you will have very less temperature in the negative, so going to minus 30, minus 40, sometimes even less than that in areas like Siachen. And it must also work where the temperature is crossing 50, plus 50. And so this is one challenge, the very wide temperature range. The same equipment must also work when the humidity is very high or when there is a dust storm. So it must be fully sealed. And sealing not only from these physical things, but also from electromagnetic radiation. So EMI, EMC. The war can be, if the war happens, you cannot say like previous times, earlier times that, okay, now the sun set, so we'll not fight, we'll come back tomorrow morning. The war is today 24/7. And therefore your equipment also has to work 24/7. And not only 24/7, till the time the war goes on. So you don't know how many days. So continuous operation, that means whatever the thermal energy that is being wasted by electronics or whatever devices, that needs to be efficiently taken out to the atmosphere, and cooling has to happen to the required efficiency. So that is something which is very, very important, and that sometimes makes your system bulky. Again, if it is an airborne equipment, you cannot have the bulk. So you need to balance what has to be done. Vibrations and shocks, we were actually discussing, there was a time when there were no roads available, the equipment, and even if the roads are available, the equipment that is going in tank, it has to undergo whatever shocks and vibrations that are required in the ground vehicles. So Similarly, for the airborne helicopter has a lot of vibrations, and especially the rotor frequency creates a lot of problems, 27 hertz and the harmonics. So it has to withstand all that and still perform. High reliability, you cannot afford to fail. So when it has to work all the time, so assured quality. And if it fails, we should be able to replace the defective part or repair that very fast. So very, very low mean time between failures, and again, mean time to repair. They have to be very, very low. The equipment should be, the lowest educated person should be able to operate the equipment, because most of the equipment will be operated by Jawans. They are not very highly qualified. So the equipment must be easy enough to be operated by the Jawans, the other ranks. And if there is a problem, the engineers should be able to take care of it. Again, when we say engineers, they may not be qualified engineers, degree holders and all that. Even ITIs are sometimes called engineers. So ITI, diploma holders and workshops at various locations, whether they are field workshops or formation workshops or base workshops, OEM. So these are various kind of layers that need to be built in. And if there is a failure, the failure has to be a degraded failure. It should not be catastrophic failure. So, and there should be backward compatibility. The new equipment should not require many more new equipment. The current equipment that has been developed must be compatible with the existing equipment in the whole ecosystem. So these are some of the challenges that need to be taken care of when we talk of the defense R&D and defense equipment. And the opportunities. See, today government is very, very sincere, and they are determined that the whole of country approach has to be taken. And that whole of country approach means the government laboratories, the academia and the industry. And you would have heard in the budget of this year, Honorable Finance Minister, she announced 25% R&D budget for academia and industries. And that is what we are very sincerely pursuing. Department of Military Affairs in the Ministry of Defense has already promulgated a list of 310 items, which they call negative list, which means these items will not be imported by the country. There's a very, very positive statement given by the government that these 310, they could be systems, subsystems, components, subassemblies. These items will not be imported by the country at all. And there's a very positive statement that gives all of us a chance to look into our strengths and our capabilities and work for those particular technologies or systems that can be made in the country. From Defense R&D, Department of Defense R&D, we have also promulgated a list of 110 items which are reserved for R&D by industry. We don't want to take any research effort in that area. Of course, we will support all the research efforts. We will also provide our test facilities, whatever we have. But we want industry to take lead in those 108 areas and do the R&D in those systems and subsystems. You also hear various pronouncements from the government talking about the Atmanirbhar. And this Atmanirbhar, as Honorable Prime Minister said, made in India, make for the world. So make in India means domestic consumption is not the only thing. Make for the world means we must be able to export that particular item. And if we want to export that item, we must own that IP. You cannot buy the technology and export it. We must own that IP. And that will happen only if we do the R&D here. So, and another thing is that government is determined to bring the export to $5 billion. I am talking of the defense exports, $5 billion by 2025. And we are somewhere around 11,000, 12,000 crores now. $5 billion is about 35,000 crores. So we need to, in next 3 years time, we need to triple that capability. 3 times we have to increase the capability. So there is a huge scope, and the government is fully determined to support all of us in that effort. Also, the government's resolve is to be $5 trillion economy very soon. Probably we would have been by this time if Corona had not happened. And there is a huge role of manufacturing sector in this particular area. If we have to become, today we are about $2.6, $2.7 trillion. But if you look at the highest economy, that is the US, which is about $20 trillion. The China is about $15 trillion. Today, I told you our R&D budget is something like 6% of the defense budget. But if you look in the terms of GDP, it is something like 0.5%, 0.6%. All the advanced countries, the countries which have high technology visibility, those who are technology leaders, they are spending in 2 to 3% range. So this will happen only if we increase our economic size. That is not only percentage, in terms of real money, it has to increase. Then only we can attain the technology leadership. But that has to happen. Having said that, it is not really the money that only matters. The willpower of the people also matters. So, which is where we also need to contribute. So let me also tell you what are various ways by which we can support the academia, the students, and also the young entrepreneurs. We have, as I said in my own department, I have multiple schemes to support the academy. These are directed research centers. Today we have 10 directed research centers. I will tell you a little more in details. We have 4 research boards working in different technologies: Naval Research Board, Armament Research Board, Aeronautics Research Board, and Life Sciences Research Board. So these are all working, these directed research centers, and is working in translational research. The research boards are working between translation and the blue sky. The extramural research works for the blue sky research. What probably somebody is talking about, somebody is talking of that science fiction kind of thing. Can it happen? We will fund that activity as well. And of course, contracts for research services, that is the immediate requirement, immediate problem solving, that kind of thing happens. So there are 4 avenues available for DRDO and academies to work together. We also work with CSIR, DST, and think tanks, etc. And with industry, we have joint development contracts, development partner scheme, production partner scheme, a very specific scheme called Technology Development Fund for startups and MSMEs to do the research where the TRL, the technology readiness level, is somewhere around 4. We know the technology, but we have not done it. So that kind of thing, we are able to fund today up to 10 crore, but we have put up the papers for submission for the approval of the Honorable RM for about 50 crore. We will be able to go after his approval. And every year we have this Dare to Dream contests. I think this is wrongly written here, 2018. Every year we contest. It started in 2018, and 3 times it has happened. The 4th one is going to be announced very soon. So what technologies to be taken? Those technologies are actually driven from the strategies that our defense forces will have against our adversaries. And who are the adversaries? It all depends on the countries where we want to be in the community of nations. So all that tells us which technologies, that analysis tells us which particular academic institutions, which particular industries, and like that we all work together to develop those technologies. So today we have these 10 centers available at various places in Delhi, Hyderabad, Kolkata, Chennai, etc., at various places. And these are some of the research areas that are going on in these universities and IITs. When I say these IITs and universities, they are not limited to the research being done by them only. They are only for coordination. The research can happen in any of the IITs or in any of the universities in the country, or sometimes even abroad. Our professors can actually tie up with the professors abroad. If there is some gap in technology readiness level, we can tie up with the faculty abroad, and together we can do the research. So these are only coordinating nodes. It is not that the research in these areas will happen only at that location. So starting from agriculture, and this agriculture is mostly the high altitude agriculture, to missiles, morphing technologies, aircraft technologies, and things like that at various locations, cyber security, robotics, ballistics, advanced ballistics, protection, special structures, molecular approaches for improving human performance at high altitudes, biosensors, laser-based technologies, vulnerability discovery, malware analysis, aerospace materials, high temperature materials, advanced material processing, adaptive manufacturing, additive manufacturing, adaptive optics. You name the area, more or less everything is covered, advanced vehicle technology. But this is not all. We are setting up 5 more new centers in, again, areas that have been identified, more areas at IIT, Kanpur, Roorkee, Jodhpur, Hyderabad, and PHU. In, again, very many identified areas. And these are yet to be approved, but the discussions are already on in these particular fields. So any one of you that you want to participate in these, any one of those which I have showed earlier and in these new ones, you can also participate in the research in these areas. Again, the research boards, various research boards, number of research projects going on. I am sure one odd faculty may be doing research in some of these here also. And actually your imagination is only the limitation. The funding is not an issue. If we can imagine a good project, the funding will not be an issue. That much I can assure you. This is the blue sky research. If you think that something can happen, there is somebody who is talking about, and let us also work and find out that some good application can come out in defense. We can fund that as well. And all this IP that is generated either at your places or within the DRDO system is, we provide the support for patenting. So you need not worry about patenting. You just tell us that this has been done. We will do all the groundwork, the patent fee, the administrative work for you. And we will patent that particular technology. If it is a DRDO funded activity, it will be joint IP. So that is the only limitation. Oh, this is not coming. Can you reduce that? Okay, some of the, yeah, maybe it's slightly better. Some of the things that the students can take advantage, young and budding entrepreneurs and researchers can take advantages, the MTech in defense technologies. So this particular activity, this particular course has been approved by AICTE. And already 129 students in various institutions are undergoing this particular course. We have 6 specializations: aeronautics, naval systems, explosives, the directed energy, like that. We have 6 verticals. These students will get a chance to work in DRDO laboratories or in the defense industry in the country. And of course, we cannot guarantee the job because we are in the government system. There is a procedure in the government. But if you do a good job, as you know, in the private industry, generally, if you do a good job, they will absorb you. So that is where this thing comes. Or you can also become a startup entrepreneur tomorrow. So that kind of knowledge you will get as to what is required in the area of defense. We also have a scheme which is approved by MHRD, then now Ministry of Higher Education, the Department of Higher Education, wherein 500 PhDs are to be done by the country, the students in the defense technologies. And the funding can happen either through OH31 grant that you get in IITs, or sometimes we can also fund if there is real crunch in funding. And I spoke to Secretary Higher Education. He said if there is real crunch, then he will be willing to increase that OH31 also. Yeah. So we keep on having this Dare to Dream contest every year. Time over? Okay, that's the last, I think. So Dare to Dream contest every year, and you can participate. You give whatever ideas you think are in various themes, the students and the entrepreneurs. And if they are found to be good, we can fund them for realizing the dream into the reality. And grant and aid, as I said earlier, different way. And of course, limited period internship, what Director IIT Gopal was mentioning, we can provide that as well in our laboratories. Yeah. And these are some 46 students already doing the PhD in these areas at various places. There are various ways by which we can engage the industry. And the most important for the young entrepreneurs is the TDF, Technology Development Fund. Today, we already have 56 projects running at a cost of 230 crore. Already 2 technologies have been indigenized and 4 are going to be over there in the evaluation stage. They'll be available in next maybe 2 to 3 months for our forces. So with this, I actually want to end here. What I want to tell you is that there is no dearth in opportunities that are available. The most important thing is we should identify what is our strength. If we are able to identify our strength and if we are able to channelize that strength into what we want to do, we will definitely succeed. Success does not mean that always whatever you wanted to do, you have done it. There will be failures. There is no doubt in that. But success means that you will learn from those failures. You will fall, but you will not fall permanently. You will rise up and walk again. If that you can do, I am sure the whole of your life will be very, very happy. Thank you very much. I'm open for question if the time allows.
Thank you very much, sir. I would request Director Sir to present a memento to Shri H.P. Srivastava, sir.
So,
He's the member of the Council and Chairman of Indian Biomedical Skill Council and a distinguished senior at Niti Aayog. Dr. Sharma earlier established the Healthcare Technology Division at NHSRC under the Ministry of Health and Family Welfare and was the founder director of WHO Collaborating Center for Medical Devices. His past experiences includes that at Sri Sathya Sai Medical Institutions, as a consultant to World Bank, as an advisor consultant to the World Health Organization at the Geneva headquarters. He has authored over 50 research papers, several technical compendiums, and 3 books, besides contributing to a number of WHO reports. He has 3 academic PhDs, and his training includes that at AIIMS New Delhi, PMDA Japan, Uppsala Monitoring Center Sweden, JBI Institute Australia, and Harvard School of Public Health USA, and Tata Institute Mumbai. So now I would like to invite Sir to present a speech.
Thank you very much. Am I audible? Am I audible?
Yes, sir. Yes, sir.
Thank you very much. Thank you very much. Namaskar to everyone. and thank you for giving me this privilege to be with all of you. I am at Vishakhapatnam, which was hit by a cyclone yesterday, so I couldn't travel to Roper. But I think the speaker before me has, in principle, touched the same elements as I would touch in my field. It is also interesting how the defense and our defense technology and medical technology are combined. Defense technology keeps us strong from enemies outside. Medical technology keeps us strong from enemies inside. The cancers, the COVIDs, the tuberculosis, the leprosy, the heart attacks, medical technology keeps country safe from inside. So one is fighting an enemy which is within the society, within our lifestyle, within the diseases and viruses. And one is a technology that keeps us safe from enemies which are outside. And I'm glad that the IIT Roper has combined these two themes in one session. I will be sharing my presentation with you. To share with you, and please let me know when you are able to see my screen. You can just give me a thumbs up or a raise hand so that I know you can.
Yes, sir, the presentation is visible.
Thank you. So I am representing Andhra Pradesh Medtech Zone, which is a national project at Andhra Pradesh at Vishakhapatnam, next to the Eastern Naval Command and next to the Vizag port. We are world's first integrated medical technology manufacturing city. We are spread over 8 kilometers and we are world's largest cluster of medical devices. This is the only place in the world where from an N95 mask to indigenous MRI, all categories of medical devices are produced in one single place. The reason why we are there is, you look at this graph, this is the graph of India's import-export trade, which we make on behalf of Kalam Institute of Health Technology. Kalam Institute of Health Technology is the Government of India Project Institute for R&D and trade policy on medical technology. And if you see this graph shows that 44,000 crore worth of medical equipment is imported in India every year. And what is imported is almost everything that we need. We also export about 19,000 crore worth of medical devices every year. But these are high volume, low cost devices like syringes, gloves, and so on. Whereas most of the technologically complex devices are imported in India. Now, if you follow the graph which is on the lower side of the page, you will see two lines, one green and one blue. The blue line was our growth rate of import from 2016-17. From 2018-19 onwards, there is a projected increase in growth from the past rate. At that rate, today we would have been importing 66,700 crore worth of medical devices per annum. But we are importing only 44,000 crore because something happened in 2018-19 which changed the course of medical devices history in India. And that something was AMTZ. From being a net importer of medical products, you see, medical devices is also a very heterogeneous field. An N95 or 3-ply mask is actually a textile, but it is a medical device. An RT-PCR kit is biologic, but it is a medical device. A superconducting magnet-based MRI is also a medical device, and a Fitbit or an ECG machine or a defibrillator is also a medical device. A titanium or cobalt chromium implant that goes inside hip or knee is also a medical device. So our heterogeneity is very huge. To support that heterogeneity, large number of scientific centers are needed to support ideas, prototyping, batch production, and full-fledged production. And for that, to cater to all various categories of medical devices, right from a medical textile to an MRI, from a surgical instrument to an implant, we need 18 high-end scientific facilities to support medical device R&D and manufacturing. And I'm very proud to say that if there is one campus in the world which has all the 18 industrial centers to support medtech manufacturing and research, it is AMTZ Vizag in India. Shanghai International Medical Zone in China has 11 centers in one campus, and Philadelphia has 6 centers in one campus. But Vizag in India has all 18, right from a 40 gigahertz dual mast antenna EMIMC center to one of world's largest 3D printing center, to gamma irradiation plant, to lasers, to MRI coils. We have put all the centers in one single place to support what is needed. And because of what we did, you will be surprised to know that at the peak of COVID, India needed 11 lakh RT-PCR COVID kits every day. And in that 11 lakh RT-PCR kits needed every day, 10 lakh RT-PCR kits needed every day were supplied just by AMTZ. That's from Leh to Kanyakumari, from Aizawl in Mizoram to Dadar Nagar Haveli. 10 lakh COVID RT-PCR kit can be produced in one single day at AMTZ campus, besides about 100 ventilators every day, 500 to 1000 oxygen concentrators every day, and large number of other things. I have already shared with you that we have lot of facilities for R&D, production, batch production, and many of these things are actually common areas of work. For example, the National Dialysis Program of India, which I designed in 2015, late Shri Arun Jaitley ji actually announced this program in the budget that year. This program provides for a 10 to 20 bedded dialysis center in every district of India in public-private partnership. But India never made a dialysis machine. Now we have started making that. India also never made dialyzers, which are used in dialysis machine, which is polyether sulfone extruded membrane, about 2.5 kilometers of membrane, which goes inside every dialyzer for dialysis care. Today, we have a center for extruding polyether sulfone membranes. And therefore, large number of facilities. One of the areas of strength that we have brought in, created in the country, is to see if core components can be made. Because if core components can be made, everything else can be made. Whether it is lens, which is the core component of endoscope, laparoscope, gastroscope, and so on, or whether it is magnet, for example, which is made at 4 Kelvin helium temperatures, cryogenic cooled magnet for 1.5 Tesla MRI. These core components have always stopped the country from achieving self-sufficiency and exportability in a sector. What we have tried to do is to resolve the problem of core components. Let me change my slide. You would be also happy to know that if there is one place globally which is recognized by WHO to be the world's only WHO Center for Health Innovations, that's Kalam Institute of Health Technology at AMTZ. It is not one of the glorious universities like MITs or PITs or VITs globally, but it is Kalam Institute which carries the mantle of selecting innovations for medical technology and innovations for the World Health Organization. My previous speaker also mentioned something very important: postgraduate program in defense technology. It is so well positioned because lack of such programs and our always following the traditional path of MTech in mechanical, electrical, electronics have actually taken away a huge opportunity. And these MTech programs are extremely important. In our case, it is even more important because if somebody were to make an MRI machine in Germany or Finland, they can come to Mehboob-Nagar, Murshidabad or Meerut to install the MRI. But if we were to make an MRI or a CT scan, we cannot go to Germany to install or Finland to install, because medical technology is a regulated profession in those countries. So under the Ministry of Skill Development, we have created Indian Biomedical Skill Council, which is a sector-specific skill council, which gives international equivalence and accreditation to all practitioners of medical technology in R&D institutes, academia, research, production, and hospitals. We have also launched, along with SkillLink, which is a very well-known edutech firm, Kalam Institute and SkillLink master's program in medical technology. And I sincerely urge students to look at programs like defense technology that the previous speaker mentioned, or medical technology, to super specialized beyond their current academic achievement. Because it is these super specializations which will make you unique and will also be very critical to country's growth. Besides the advanced centers of additive manufacturing, implant making, and this is a very, again, a critical example. You see, 800 crore worth of implants are used in India every year on hip and knee. Every artificial joint implant needs on the edge, on the joint, ultra high molecular weight polyethylene, UHMWP. India never had UHMWP. We used to import it to manufacture implants. World's second and India's only center of ultra high molecular weight polyethylene is what we also have, which supports huge number of implant manufacturers in India. Now, if any of you would like to do projects, fellowships, or work in these high specialized facilities, carrying forward your knowledge of metallurgy or mechanics or electronics into biomedical engineering, we would be happy to support. Some mobile RT-PCR vans to programs with Uber India to provide oxygen concentrators pan-India on rent, just for 400 rupees a day. All these programs which are of service delivery nature also exist with manufacturing of products. And there are certain innovations. For example, when there was oxygen shortage in the country, people were putting in PSA plant, but a PSA plant can support only one hospital. And look at this image, which is a PSA plant on the truck, which can go from hospital to hospital generating oxygen for anybody who calls without an investment, just on rentals. These programs are entirely supported by projects that our students, fellows, and scholars do. Today, we supply products to each and every state and union territory of the country. There is no state and union territory of the country which does not get ventilators or diagnostic kits or oxygen concentrators or other life-saving products from Vizag Medtech zone. An international footprint which is converting India from a net importer of medical devices to a net exporter. This is a picture of Thailand, Vietnam, and many other countries which used to supply us medical products. Today, we supply to them under the national aid program. This is a picture where it is Thailand who was in recipient of our oxygen concentrators, which go in INS Eravat or some ship that Navy provides us from Vizag port to the rest of the world. We are also the only PSU which is member of the BRICS Manufacturing Business Council. BRICS Business Council, which is Brazil, Russia, India, China, South Africa, led by the 5 prime ministers, has a manufacturing working group, and we are the only members from the public sector in that group. This pyramid that you see, and there is one thing that I have not mentioned to you, AMTZ not only is the world's largest medical devices manufacturing cluster, but also a cluster which is world's fastest built industrial zone. We were built in 342 days. 3rd January 2018 to 12th December 2018. In front of every building in the zone, number of days taken to build it is mandatory to write it. The building in which I am sitting, for example, was built in 113 days. This 5-story glass pyramid, which is our WHO collaborating center, is a 36,000 square feet building housing WHO innovation and R&D, was built in 36 days. You can see written on the edge of the building. Because in medical science, generally the patients don't have even 5 minutes extra. And therefore, time-bound execution of work is something that we thrive in. These are some of the live pictures. And the entire chronicle of creation of medical technology ecosystem in India and the role in COVID is documented in this book, Made in Lockdown. Feel free to grab a copy on Amazon. And if you like it, do write to us. If there is anything we can do with you, for you, and along with you, we would be happy. And thank you for the opportunity. Jai Hind.
Thank you, sir, for the briefing. Now we'll have. Thank you, sir. So now it's time for a short tea break. You all are requested to gather again here within 10 minutes, and then we'll proceed further. Once again, I welcome you all. Technology is a great boon that has made our lives much better, and it is continuously advancing further. So, our next speaker is Mr. Abhishek Goyal, Vice President, Global Practice Head at Infosys. He has 25 plus years experience as an industry and business transformation leader in digital engineering, IoT, engineering cloud, and emerging tech at Infosys Limited. He is an alumnus of IIT Kanpur and XLRI Jamshedpur. He also licenses and leads several programs with local industry bodies like CII, NASCOM, STPI, and academic institutions at UG and PG levels. He is currently the NASCOM SIG leader for Punjab and Chandigarh chapter. He is a proven thought leader who and also holds a US patent from the USPO. He is an author of several white papers in international forums. Now, I would like to invite Sir to give a talk on the.
Sure. Can you hear me?
Yes, sir, you are audible.
And I'm trying to share my presentation. Is it visible to you in the audience?
Yes, sir, it's visible.
All right. And I can't see the audience. I can see the dais. So if you can just try to understand who are the people in the audience, what's their profile, and how many people are listening to me.
Yes, sir, we'll try to adjust the camera.
Okay.
You can see some 300 people are listening. They're all engineering graduates.
Sir, there are approximately 300 people present here, and all are from engineering background.
And they're mostly students from the fourth year, third year. What is their profile?
Yes, sir, most people.
Dr. Abhishek, this is Naveen. So we have about 300 students right across the Punjab, from far away from Hoshiarpur, Kapurthala, and our own students. They are ranging from BTech first year, second year, third year, final year, or from master students, as well as our PhD students, not only from the technical background, but also from the science background. So it is honor for us to be you have here. So I hope our director is on the dais. The Srivastav from TG DRDO is on dais, and Dr. Karthik Kumar from Saint Govind is on the dais. Earlier we were having the Dr. Dipen Sharma from who is CEO MD of AMTZ was here. So I welcome you here. Yeah, please. You have any other query? Yeah, please.
Sure. Dr. Naveen, thank you for hosting me on this prestigious event. And I'm also looking forward to hearing ideas, views from the other panelists on the dais. And I'm looking forward to a great session with all the students and the faculty. So quickly, my background, as being told, I am also an IIT alumnus from IIT Kanpur, 1995 batch. I had done BTech in mechanical engineering. And as of today, I run the digital engineering practice for Infosys globally. And I have a team of almost 6,000 consultants, mostly engineers across the globe, serving the global 500 clients. It's my pleasure to be here talking to all of you. And the topic today that I chose is something which is very close to my heart. See, we all as IT professionals, we all as engineers, we always think of IT as probably a piece of code, a piece of software, which is programmed or configured and does something. So having spent 25 years in the industry, I would say that's a very myopic view of IT and software. We should look at the entire IT paradigm, the entire IT ecosystem, which actually solving some real life problem. The problem could be for the country, it could be for the society, it could be for people, it could be in the field of healthcare, it could be in the field of education, it could be advancing the science. So that is the larger purpose of technology, and I will use IT and technology interchangeably. And I think the students who are passing out or who are doing graduation, they should keep that larger perspective, larger cause always in mind when they are working on any of the IT projects or when they're learning anything. What's the larger cause? Who is the end user? What's the benefit that the solution can bring to someone or to a group of people? I think that understanding is of paramount importance before we start doing anything else. And once you understand the larger perspective, automatically and logically, you will find how your solution fits in, what skill sets, what value you can bring to the table, being an engineer. So that is why the topic for the session is called Tech for Good. Means how we bring software and IT and technology in the lives of people and combine with the power of people, combine the potential of people and the potential of technology together to amplify for the common good. I have around 8 slides. I will take 20-25 minutes to go through them. But you are more than welcome to stop me in between and ask me questions. And I will take a practitioner's view. I have a lot of learned professors in the room who obviously can go into the depth of technology much better as compared to me. But I would take a practitioner's view based on my experience in the industry, working with various clients on their actual real life problems and how technology can be used or has been used for various end purposes. So you can see my slide, right? Can someone confirm? And can you hear me as well clearly and loudly? Can someone confirm, please?
Yes, sir, you're audible and visible.
Okay, thank you very much. Because sometimes when there's a pin drop silence, I get concerned whether I've lost the connection or coming back. All right, so we'll proceed. So what is tech for good, right? So tech for good is something, any kind of technology which leverages the technology advancements to build solutions that can help improve our societal, environmental, people or economic problems. It is technology is not inherently good or bad. It is, I think we can't say technology is good or bad intrinsically. How we apply technology in what domain, in what sphere, and for what purpose, that defines the good and bad about technology, right? So the outcomes are a function of the application, not a function of the design, not a function of the technology per se. Technology, if you combine with the potential of people, the human capital, and the software programming, it becomes a potent solution which can solve a lot of problems. But we always have to keep the human-centric approach in mind. There's a lot of background noise. If people can go on mute if they're not speaking. So when I say human-centric, what it means is you have to empathize with the person who's going to use your solution. You have to take the use case from the end user perspective. You have to think from the day in the life of the end user, understand what problem the end user faces. It's a person in most of the cases. What's the problem of the end user? The end user could be the supply chain manager, it could be the design engineer, it could be an aircraft engineer, it could be a quality assurance person, it could be a salesman, a salesperson. So how we can ease their work, how we can bring efficiencies in their work, how we make the data more transparent, more visible to them, so that they are able to take the key decisions in a faster and more accurate fashion, how we improve the overall outcomes. So we have to think from the perspective of the end user, that's the application part of it, and work backwards from there to design your solutions. That's the human-centric approach. In the traditional approach, the IT companies used to say, okay, I will build a software, I'll build some application, and I will take it to market and customers and people. And if they want my software, they can buy it and use it as they want. If they don't want to buy my software, that's fine. I think that approach, which is probably approach of making and then selling, is not going to go forward too much. What we require is understand what is required first, who are the people, who are the personas, and from there you design your solution. That's a human-centric approach. People call it by different names. Some call it design thinking. Some call it human factor engineering. Some call it human-centric design. But ultimately, it means the same thing. Guys, 1 second, team. There's a lot of background noise at my end, probably. Just give me a second, please. Sorry, I'm sitting in Infosys Mysore campus. There's some team meeting going on. Okay, so the left-hand side chart that you see is from a research paper of McKinsey. And McKinsey also did some analysis, and they found out the areas which are impacted by technology in a large way. So as you can see, on the x-axis are the various dimensions around job security, the living standards of people, the education, the healthcare, the diversity and the opportunities for the jobs. And the very important factor is the entire ESG, the environment, social and governance. How do we make our society more environment conscious? How do we make the world more carbon neutral? How do we bring in more elements around sustainable energy, right? How do we reduce energy consumption? How do we bring in new sources of energy, the renewable sources of energy into the mix? That's the environment part of it. These are the areas which we want to impact. And from the technology perspective, if you look at the y-axis, the vertical axis, there are various digital paradigms emerging, and some are quite mature. So data and AI obviously has a big impact. Without data acquisition, data assimilation, data orchestration, data analytics, and we really can't make a big difference, because data gives us a lot of insights into the historical patterns, and data can also give us intelligence as to what can be done to improve on these dimensions. So data and AI has an impact on all the sectors. The dark blue represents the high impact and the light blue represents the low impact. Similarly, connectivity could be through 5G or RFID or any other technology. So how we connect the ecosystem, connect the people, connect the data, connect the things, connect the processes in a wireless fashion, right? So that is the power of connectivity, and obviously there are various platforms that are required. Platform means software platforms which are required to build in the various applications and the connectivity layers. Robotics is quite prominent in the medical industry, as you would imagine, and also in the manufacturing industry, and also for hazardous jobs. IoT is Internet of Things, again, linked to data and connectivity. The world is a connected place. The people are all connected. So IoT further enhances the connectivity paradigm and try to bring in data, trying to bring in seamless integration. Again, a very important element. Augmented reality, again, in the field, in the age of metaverse and whatnot, right? Augmented reality, virtual reality will be very, very prominent. We'll have digital avatars of each one of us. We can have virtual experiences of showcases, of seminars, and we can be simultaneously present in multiple places because we'll have multiple digital avatars. So that's the power of augmented reality, and so on. So this is about a high level framework that I want to use for some of my future slides. If there are questions, I can take up now, else I can proceed. I'll just take a pause for 5 seconds to see if there are any questions. Okay, looks good. Let me proceed. So there's a multi-fold impact of tech for good. And as I already called out few areas, but let me do a slightly more deep dive. In the healthcare and safety, right? In the age of COVID, Pfizer, Moderna, right? Or in India, Serum Institute. So all these firms had to quickly come out with the new recipes for drugs, had to quickly roll out the new vaccines, starting from scratch. Typically, the lead time for a vaccine development and rollout is 3 to 4 years. But in our case, the vaccines had to be conceptualized, designed, manufactured, tested, trialed out, and then rolled out in a span of 6 to 8 months. So technology played a big role there in terms of simulation, recipe management. There are multiple solutions on product lifecycle management and lab informatics management systems, LIMS, and clinical trials. And a lot of AI and ML was being used to predict based on whatever limited trials they could do. So it was again tech for good, a good example of tech for good. If I look at the sustainability environment, electric vehicles will become the norm. Electric vehicles will replace the IC engines. They will not consume the fuel. They'll be running on the battery, and batteries would be charged through the electric charge. And the electric charge would probably be powered through some solar panels in the background. So ultimately, the solar energy is getting converted into electrical energy and then into a chemical energy, which then again converts into the kinetic energy for the car. So that's the concept of EVs. It will replace all the fuels, and hence the carbon monoxide emissions will come down. This is again an example. A lot of software and technology, a lot of engineering goes into making electric vehicle. I myself run the practice for electric vehicles from the software perspective in Infosys. And we are working on a lot of software solutions around charging as a service, how to enable the charging stations, how to look at the consumption patterns, how to optimize the charging, how to make it faster, how to make the seamless payments while you're doing charging. So a lot of software wrapper solutions around the core engineering is something which technology is doing along with the engineering functions as well. A good example of sustainability. One more example I want to call out is all the buildings, the campuses, the stadiums, the airports, the public places, malls, multiplexes, they all have chillers and heaters, the HVAC systems, and humongous number of lights and electrical equipments. They all consume energy and they all emit some kind of carbon. They leave a carbon footprint. Through technology, we are trying to connect all these devices through beacons, sensors, through various network connectivity protocols. All this information is getting captured in some command center, which is running on the cloud. And the data is being used to predict the consumption patterns, also to see where there's a wastage of electricity happening, where there's a wastage of water happening, and how that wastage can be minimized or reduced. How we can auto dim the lights if there's nobody. How we can use the ambient temperature to a better effect instead of using AC in a large fashion. So all this is coming through some solutions which are IoT driven and cloud driven, which are called BMS, building management solutions. Again, a great place to drive sustainability. All the Infosys campuses worldwide. I am sitting in a Mysore campus, which is 450 acres. all the buildings are LEED Platinum certified. What it means is we are carbon neutral. We try to minimize energy consumption. We do carbon sequestrating for the local landscaping and farming in the campus. We do rainwater harvesting. We have command centers and control systems for automatically managing the ACs and the fans. So a lot of things can be done using technology to drive sustainability for the future. I'll take 1-2 more examples, then we'll go to next slide, otherwise it will take too long. Even in the area of farming, India is probably 60% agrarian economy still, right? So how do we increase the farm yield from the same piece of land? How do we give more intelligence to farmers wherein they can grow the crops, what are the crops, put the fertilizers, whatever is required in the right amount, how to prevent any insects from plaguing the crops, how to maintain the water moisture, and how much to maintain. So all these are parameters which we can analyze using IoT. We can put small sensors. Sensors are quite cheap these days because of the pervasiveness of it. Data acquisition has become quite cheap. You acquire the data, you give the insights to farmers, they can take the necessary interventions. In Israel, they use a lot of drone-based farming. So drones actually, they do the irrigation or they drop the pesticides from the top, or they take the pictures of the farmlands, and through spatial analytics, the drones are able to tell how the crops are doing and what intervention needs to be taken up. Education, we saw in the COVID times, all of us shifted to online education. If we didn't have platforms like MS Teams or WebEx or Zoom, I think we would have struggled. While I spoke about the good aspects of tech, we need to be wary about the inherent risks that tech brings. Again, it depends on what is the intent of using the tech and who is using it and what's the end purpose. People can abuse tech as well. Some of the risks we have to be aware of as global citizens, and when we join the industry, we need to ensure that we manage these risks very well and only look at the good aspects of tech. There is a debate, there is a divide in opinion on the employment aspects of the impact on the employment because of tech. The more robotics you do, the more RPA you do, the more bots you use, the more automation you do, obviously you cut down some of the mundane jobs. So it will lead to some kind of unemployment. But again, people say that while we are cutting down the mundane jobs, we are creating equivalent number of more high order jobs. But people who are at the bottom of the strata in the society, who are not probably fully educated or who are semi-educated, who can't adopt the new tech, yes, there's a threat for their employment to some extent. Technology has also created a big digital divide. There are people like probably most of us in this room who have access to tech, who are tech savvy. So we get access to all the government schemes, we get access to all the information, we can make the right decisions, we can grab the admission seats in the good colleges because we know how to use the tech. While people who have not been exposed to tech as yet or who don't have access to tech as yet, they obviously are losing out. So it's creating another kind of divide in the society, which is called the digital divide. Earlier, the divide was based on city versus villages, educated versus non-educated, rich versus poor. Some caste-based discrimination used to be there. Now there is a divide based on the digital quotient of the individual. The more digitally savvy you are, the more likely you will succeed. So that's the reality. A lot of tech is being used to spread malinformation, fake news on the social networks. Political parties, fringe groups, they use the social platforms for biasing the opinions, misguiding people spreading the false information. So we have to be aware about this aspect of social. AI can be used either way. Data can be used in a good way or it can be abused in a bad way. There have been cases where AI has been used to discriminate people based on their caste, creed, sex, color of the skin. AI can be used to also look at the vulnerabilities in the various societal groups and target them. Data security again is a big issue. All our networks, all our systems, all our infrastructure today, all our traffic lighting, all our nuclear plants, all our submarines, everything is connected. And the entire country can come to a halt if the systems are hacked. Similarly, my personal information is being tracked by so many social apps. If I'm on the social media, my information goes to various government websites. It goes into DigiLocker, it goes to Aadhaar portal, it goes to Cowin portal. God forbid if those things are hacked, then a lot of personal confidential information can be leaked and can be misused by various people. So these are some inherent risks. So when we design any solution, we have to be wary of these risks and design solutions which are foolproof, which can mitigate these risks in the first place. Some very interesting examples I got from various papers, some very unique examples. There's a solution called RIICE, which is remote sensing based information and insurance for crops in emerging economies like Brazil, India, where they use the satellite technologies to estimate the annual rice yields. And sometimes the farmers also insure their crops in some of the other countries. So depending on what information we get, the insurance companies can do insurance for the crops. It is basically remote sensing of the crops through satellites and based on that making some information which can be used for insurance. There's a concept called BEEP, better buildings equal less pollution. This is a solution I spoke about around the building management system. AI is being used heavily by all the pharma companies. I work with a lot of pharma companies like Pfizer and Novartis, Eli Lilly across the world, and we are working on multiple AI solutions for them for expediting their drug discovery, for their protein modeling, and this was used heavily during the COVID times. Subtio, a BASF company, a German company, has developed 3D printed prosthetics and 3D printed knee replacement. And now they are making for the ears some 3D aids, 3D printed aids. Again, 3D printing is something which is a lot driven by the CAD, the software, and the PLM, and ultimately we do a image-based fabrication. In UK, a fintech company is making wooden Mastercards because they want to do away with the plastic, because plastic is non-sustainable. And they are sourcing this wood from the cherry trees and some recycled bottles. So very good examples of tech used for some good purposes. And when I say tech is not only a software, tech is a combination of some kind of software, some kind of hardware, some kind of network, some kind of technology, some kind of engineering. So I'm calling tech in a broader sense. I'm not just talking about software. Tech combined with engineers, with all of you, what you all of you do, I think is a very powerful combination. In India itself, if you look around, you will find examples where government and private sector individuals are using tech in a big way. Aadhaar is a good example. It's a meta platform driven by data and AI. A lot of things are getting linked to Aadhaar now. The direct benefit transfers and looking at the biometrics of various people for identification. And it is also helping us eliminate fraud. And as per one estimate, it has saved almost 9 billion US dollars to the government of India exchequer by eliminating fraud. Kavach is a new solution launched only 2 weeks back by the Indian Railways. It's an anti-collision system. Again, obviously it has got some mechanical and hardware electronic components, but there's a lot of IoT and connectivity in data and AI in this solution that we have made. CoWIN portal, again a good example. 190 crore Indians have been given some kind of vaccine all through this portal. Again, a good example of a huge data platform and a lot of analytics also and a lot of integration being driven into that. Electric vehicles, I spoke about it. Every company worth their salt is diving into this ecosystem. Again, it's a combination of robotics, clean tech, platforms, data and AI, and a lot of electronics and a lot of semicon. ISRO is making a lot of indigenous satellites. In fact, now ISRO is also exporting satellites and they're also giving their own facilities for launching satellites of other countries. The idea is to look at the weather patterns, to predict the cyclones. And again, there's a lot of tech which goes into, as you can imagine. The aeronautical engineers here in the room could understand what I'm saying. The smart city mission of India, 100 smart cities, which will digitalize the transformation, the transportation, the traffic signaling, the water management, the solar and the wind farms, the waste management, the healthcare, education. Again, the backbone is all technology. So this is my last slide. So to conclude, I would say technology in isolation, a software program in isolation, just a piece of code doesn't mean anything unless it is creating good for someone, unless it touches the masses, and unless it is affordable and democratized. Tech can't be limited to few people. Tech can't be so expensive that nobody can afford. Tech can't be so complex that nobody can understand. And tech can't be so contained that it doesn't reach the masses. Tech is something which has to be democratized, which has to reach everyone and touch everyone's life. Then only it has the purpose. So some design principles that all of you students in the room as budding engineers and technocrats and techpreneurs going forward should keep in mind is, and this is again based on my own experience, take the design thinking approach, which is a DFE framework, the desirability, viability, and the feasibility framework. Keeping the end user in mind, always keep the business, the user at the center of your solution and work around that. That's a design thinking approach. Don't try to define solutions which are so monolithic or so big that it becomes very difficult to implement or very difficult to execute. Take a MVP approach, agile approach, define the use cases for the end user in a modular fashion, work on use case by use case. Deliver 3 use cases, work on 2 more use cases later on in the version 2, take up 2 more. Don't try to to build big monolithic softwares like ERPs of the past. Bring more API microservices based approach when you're defining solutions. Adoption of green IT, very important. There's something called green IT. All the profs in the room would know that very well. How to make IT itself more sustainable. How to ensure my data centers are not consuming too much of compute. They're not emitting too much of carbon. How to ensure I have digital work instructions for people on the factory floor. I don't use paper. How to ensure that technology is driving down the waste. So all these aspects of green IT, again linked to sustainability. Tech should ensure that the data is secured always and the safety is not compromised. Again, we can define a fantastic solution, but it is always getting hacked. That's not good. Take an agile and product-centric approach. Sometimes we try to take a more of a project-centric approach wherein we define the project, we define the schedule, the cost, the people, we define some outcomes. And in that approach, what happens is you are always focused on what you want to do. You're not focused on what the end recipient and beneficiary wants to have from you. When with the product-centric approach, you keep the end product, let's say a car in mind. And when you think of a car as an engineer, you will say, okay, my car should have these kind of safety features, should have 6 airbags, should have these kind of headlight, this kind of tail light, this kind of seats, because my end user is a urban middle class person, right? Who would need this kind of features. So have the end user, have the product, have the feature in mind, and then engineer, then design, then do manufacturing. Instead of trying to define something and then trying to sell it. That's the product-centric approach. I think all these points are interlinked, but it's very important to understand. There's a nuance to all this. Agile means you have to be flexible and continuously improvise on the fly and not get stuck to one approach or one solution. Learn, hear, improvise, deliver, then again learn, then the cycle continues. Last, the human-centric engineering, again is linked to design thinking approach that keep the human ergonomics, the human ease, the human behavior in mind. You make a very fancy car, very expensive car, but the car is not very comfortable with the end user. In your mind, you have put the most sophisticated technology, but the end user is not really liking that. That's not good. So that human-centric approach has to be there. So with this, I'll stop here. I'm done with my slides. I think I'm also out of time, but if there are any questions, I'm happy to take them.
Thank you, sir, for the wonderful speech. Today, we have so many young minds among us, and your words will definitely be helpful for us in understanding the good and bad aspects of technology and how can we utilize it to help the society and for the betterment of the society. Moving further, I would like to introduce our next keynote speaker, Dr. Karthik Kumar, Deputy Director, St. Gobain's Research and Development. Firstly, I would request Director Sir to please give the plant to the sir and Dr. Karthik joined the St. Gobain Research and Development in 2018, leading the innovation and research methodology. Prior to joining St. Gobain Institute, he has worked in Unilever R&D for 12 years. He has a MS in chemistry and PhD in chemical engineering from RPI, New York. He holds 7 patents. So I would like to invite Sir on the podium to give us a wonderful speech.
Thank you. Thank you. Good afternoon, everyone. Good afternoon. Thank you, sir, for inviting us today for the keynote speak. And thank you, sir, Chief Guest, for such a wonderful talk. Good, you are actually celebrating the Technology Day. I mean, it gives a wonderful opportunity for all young minds to think what technology means and how we can enable this. Today, I'm going to have a topic on empowering innovation for sustainable future. That's the topic of my talk. For this, I of course thank Dean, R&D, the faculty and students of IIT Ropar and faculty and students of our nearby colleges to come and join here. It's a wonderful opportunity to be here, and it's my pleasure. Going to my slides, I work in Saint-Gobain R&D Center, which is, if the slides are coming. I work in Saint-Gobain R&D, which is co-located in IIT Madras Research Park. We are one of the anchor clients. Thank you. So we hold 120,000 square feet there, with the first 3 floors on the street in the center, which you see. Today, I'm going to talk about innovation and sustainability as 2 keywords. I'm going to kind of define, I'm in fact going to touch a lot upon what the earlier speakers have mentioned and how it relates to each other. And then I'll give you a case study of how innovation for sustainable future is the way to go. And you could, how you could adopt your career accordingly. So first, let's define what is innovation. You have innovation right here in the placard here for the Technology Day. Technology is driving the innovation. Technology is driving the creativity. So, first thing I want to kind of differentiate is innovation is different from invention. I think a lot of people mix this up. There's a lot of confusion, like, I invent something is the same as I innovate something. I think I want to kind of differentiate that. I want to say invention is important. Invention is something which you actually find for the first time. You invent the first and patent it. But what keeps that invention profitable, alive, and ability to sustain into the future is primarily innovation. Innovation is needed. It's like having a seed is invention, and growing that into a plant is an innovation. That's a model which you can probably think about and actually feel that inventing something is not good enough. Innovating is far more important, and that's exactly one of the differentiators I want to bring. They both can be patented. In the sense, of course, the invention is to be patented, but innovation is far more important to be patented because that's what will yield you the benefit as we go forward. We had a previous speaker, Abhishek, also speak about it in a couple of tech for good examples. Now, again, I want to refer to what our director sir said in terms of, everything comes from within. The innovation has to come from within. In the sense, we have to create, be creative, be inquisitive to be innovative. And in addition to that, I touch upon the topic which our previous speaker, Abhishek, spoke, was it depends on human need and understanding consumers. But this is something you're going to keep hearing again and again in the current generation. You're going to hear that you have to innovate to what the consumers need today, not just make something and give it It's not that generation. That generation is gone. Yeah. So in that sense, we have to add value to the product. It could be business, it could be society, it could be economy, it could be country. Of course, that's what we are all here for. So one of the topic I want to talk about, and I mean, I wholeheartedly recognize what directors have said in the morning, is basically that to be creative, you need to have one aptitude for you to, if you have this, you have an aptitude for R&D. Otherwise, you may consider not having R&D is what I would say boldly. Yeah, in the sense that if you're not, you have to be inquisitive. You have to keep asking questions. You need to understand why this is happening, why, and why is this problem? How can I solve the problem? Yeah, how is also important following all the whys. Otherwise, there's no solution. Yeah, in that sense, you need to be inquisitive. Now, being inquisitive is the trait of genius. We all know that. I mean, as a child, I mean, every kid are playing with a lot of toys. You say, "Wow, what a genius you are!" Yeah, it's clearly that because the kid is actually more inquisitive. And today we are like recognizing them and saying, "Oh, you're genius," and that we stop as we learn. We stop. Yeah, that's not the reason. That today, yeah, when you are in education, you have to have critical thinking, and when you have critical thinking, it is being inquisitive. Yeah, I mean, the being observant makes you get that eureka moment. Sometimes the eureka moment just pass by, which means, you would have lost that opportunity to patent or find new thing if you are not inquisitive enough. You would have just lost it. Yeah, so being inquisitive is an important trait. Seek answers. That, of course, and we all have to use one of our wonderful tool God has given us, brain. And as director said, why are we not having a lot of technology from India? I think it all goes to what our brains are. Today we have brain is one of the topic we discuss, but there's more. Can we apply our brain to what the country needs? I think we have to keep that active, and we have to look out for it. We are not just hear what someone wants and just say and do as an action. Those generations are gone. Yeah. Last but not least, I think if you want to be a leader, if you want to lead some aspects of things in life, you have to have your own thoughts and opinions. Otherwise, it's exactly what I said before. You will be directed. If you want to be a leader, everyone can be a leader. There's a good opportunity for us to be all leaders. And for that, inquisitiveness is one of the characters. So I leave this thought to say that, have this quality. If you don't recognize it, if you have it, grow it. I mean, just make sure you are good at it. And that's exactly what this technology and the root of what I'm saying about technology is all about. Yeah, I move on to the most important and the stages at which we do R&D or innovation. I would more focus on innovation. The first step, which is exactly what Abhishek spoke about, is there any unsatisfied needs of the customers? Are we observing that? Are we noticing that? Are we finding use case? Are we doing design thinking on the needs of the problem? So we first recognize that. Of course, then when you say how to solve the problem, we go for application test and systems design development. Then comes the R&D. Now, probably R&D for a lot of people is in the front. Yeah, you do R&D so to develop broad solutions, not monolithic solutions, as he said. Yeah, then you do a pilot trial and make sure it is scalable. It's not just one single prototype. Yeah, and then finally, it applies to a lot of industrialized mass market. So I switch gears a bit. I want to talk about sustainability. Sustainability is a very important topic. I think it's touched upon in few ways today. But in fact, I wanted to acknowledge sustainability from this institute in the fact that how they work for clean energy is something which I really appreciate, and this is something which I want to indicate how this could be also done by each one of you. Now, what is sustainability? Sustainability is something, again, a very hot topic. Why so? Because we are in I'll get a few more slides which talks about why it's so important. I mean, we are in a generation where everyone is going to be talking about climate change, climate actions. What does it mean about it? So let me first read out the definition. And it's not definition; it's kind of good meaning, which says meeting the needs of present. without compromising the ability of future generations and to meet their own needs. I think if we look at our lavish spending, our greed of materials, many times we overdo what we need. We waste food. You know how difficult it is to make food in the, you are here, you know all of that. I mean, so the idea is simple. Consume as much as you need is something what could become a sustainable aptitude or behavior. Okay, now coming to the sustainability development goals. United Nations actually developed 17 sustainable development goals. These are all of them which you will find in the internet. But most important one which is being discussed is the point number 13, which is climate action. And why is that important? I'll come to that in a minute, but sustainability doesn't mean just climate or environment. It also could be social sustainability like poverty, hunger. It could also be economic sustainability and the environmental sustainability. So all three of them, if they happen to be together, then it's a fantastic sustainable solution. Or if it's a combination of both, and any of them, it could be wonderful. Now let me come back to the climate change. The Sustainability Development 13 talks about climate change, and I have a data here which says between April 2021 and April 2022, we already have 1 ppm level of carbon dioxide equivalent increased. And this is the live data which is measured in Hawaii by the action of all the the atmospheric changes. That's the best place to measure the carbon dioxide content. This has been happening from 1955, and you can see that graph which is steadily rising from 400 ppm to 420 ppm in the matter of just 5 years. So it's really an important aspect that there's a correlation between what the carbon footprint, as we call it, to a climate change which is happening. Now, there's another factor to it, which we all know, and just wanted to highlight that through a data that in 1800, we were 1 billion. In 1928, we were 2, which means we added 1 billion only in 128 years. But we were 6 billion by 2000. You can see the graph rise on the left side from generations. And we expect it to be 9.7 billion to 10 billion by 2050, even with all the growth rate, which is reducing in many countries. So what does this mean in terms of high population? It puts pressure on resources, leading to environmental issues. That's the reason why this is an important burning topic, because it's going to require a lot more raw material. It's going to have a lot more water demand, which you all know what is happening. It's going to have energy demand, which is again a constrained resource. And of course, most importantly, another offshoot of all that is there will be a temperature rise, and that's because of the greenhouse gas effects, which is up there increasing. Now, if I were to then talk about that 2 degrees increase, today we are 50 trillion gigatons of carbon dioxide equivalent as a planet. And if we continue as we are, which means we do nothing, we are ignorant about sustainability, we are ignorant about climate change, we are going to consume as much as we want or emit more carbon dioxide, all that stuff, we will be 3 to 6 degrees higher by 2100 as per the projection. And if you do something about it, if you are containing this to 2 degrees, you have a hope of sustaining this place, and that's what the COP talks about. And therefore, there's a model. This is completely model. So that, I mean, we need to do better than this model. And the model says net zero means we need to at least get to a level of 2 degrees rise, and that's the limit we all have. Yeah, I mean, to look at it other way around. If we want to live as we currently live, we are consuming 1.7 Earth equivalents of resources. And by 2050, we need 3 Earths. But do we have it? So let me take it to what each country does. So India is consuming resources as much as Africa and all of most of the Asia put together on the top. It's not like it requires one full Earth. And Bangladesh is doing as much as what Asia is asking in terms of resources. And if you look at US, it takes 4 Earths as it's today. So I mean, how much would that mean as the population is increasing? So we need to have something done today urgently, and this is the call for, I mean, I'm not alone in say talking about sustainability. You're going to hear a lot of people talk about sustainability. So let's talk about technology and innovation around it as well. Yeah. So, I mean, what do we do in terms of, as a manufacturer, in terms of, sustainability? We do a tool called life cycle analysis, which is sometimes what they call as cradle to grave or cradle to gate. Yeah, it depends on what you use as raw material to manufacture, how does it transport, then what is the construction in terms of carbon footprint, and use. I mean, we heard Abhishek speak about, building management beams. Well, I mean, I wanted to quote how well this auditorium is built, that we are using a lot of natural light and not light, synthetic light. So this is a well-designed room. So use case will also mean lesser carbon footprint. And in some, you would say, those are the old days, we don't need AC. Today we need a lot of AC. So all these things will start coming in if you really see what carbon footprint mean in terms of use case. And finally, even destroying something which we made and wanted to kind of close will also consume carbon footprint. So it's a cycle which we understand and make sure that whether we are good about it or positively impacted. Now, there are 4 elements which we measure. That's how I spoke about carbon footprint. Then, of course, water utilization, which is a resource which is quite important. Then, of course, what we generate as waste, some of them include non-degradable waste. And most importantly, there's another aspect which we don't seriously look into, is how much toxic material is used, in terms of making some products. Sometimes solvents are used and discharged in the river. So all these things adds up. So we need to really understand this from the procedure of life cycle analysis. So with this 2 different definitions on innovations and sustainability, I just wanted to glance through what we do in sustainable innovation at Saint-Gobain. This is a kind of an industry which it can be any name, any other industry, but I wanted to give you as an example what we are in terms of doing that, so that you can feel for yourself on how we do things. Yeah. So before I do that, I just wanted to give you a flavor about the company. We are a big company. We are 355 years old, 357 actually. We present in 75 countries, and we have 800 manufacturing facility and 45 billion euro worth of turnover. Now, with such a big thing, we need to make sure we have to be sustainable in exactly what I said before. Now, sustainability is also a global phenomenon. It's just have to be very important that no one country can do. There are discussions like you should do better, I should do better. But the fact of life is we are all living in the same planet, and this is a global phenomenon which needs to be understood. Yeah. In terms of R&D centers, we have 8 centers. We have 3,600 researchers and 3,400 marketing team which works for us to get the innovation going. And this is our team of 250 people located at Chennai. And in India, we have a strong company we make glass. Many of you know with Saint-Gobain glass, but not just glass. We make abrasives and other products I'll cover. But we have 22 manufacturing sites. We use 98% of what we make in India, so actually that's important for us to also be Atmanirbhar. And these are the businesses we are in: glass solutions, gypsum for internal walls, Weber for cement mortars, abrasives, ceramics, performance plastics, which includes life sciences and automobile and also aerospace. And security is the windshield business. So these are the kind of materials and solutions we are into as a business. Yeah. So what is our motto? This is why the sustainability is important for us. This is the first thing companies have some things called purpose, and that's important for all of us to understand. You have a research thesis as a purpose. Yeah, that's important to stay focused on the purpose. Our purpose is making the world a better home. Yeah, we try to understand this in various forms. It could be most of them is related to sustainability also. And associated with that is our president committed to a net zero carbon by 2050. Now, this is the same commitment the world has to have to reduce to a 2-degree rise temperature. Yeah. So in that context, as a company, we are committed to as much as a country would commit to. And for that, what we do is exactly like the way I described on LCA. We design products and formulations which are less carbon footprint. We make our processes efficient. We use energy which are renewable and so that it's having lesser carbon footprint. We work with our vendors and raw material supplies to make sure our carbon footprint is lower. Again, while we transport, we make sure it's in a lower carbon footprint and carbon removes. But these actions are pretty much what we have in our control. What we do within our control to make sure this is net zero carbon. But the reality lies in users like you. When you make a house, when you use a shirt, when you use a product, how sustainable are you thinking in terms of all those products? A washing machine. Do I need to put a washing machine half load or a full load? Yeah, can I use can I put one shirt and turn on the washing machine? You are actually wasting resources. Most of the time, air conditioning at 18 degrees. When you really can be comfortable at 24. Yeah, today one industry which is struggling is, also associated with the sustainability is the construction industry. We are talking about sustainability of 40% impact from construction industry, and it has a 3 times resource consumption and 2 billion people now who are in urban area moving to 30. So again, it is adding more pressure on the sustainability. So what we want to do in terms of our purpose is to be the world leader in light and sustainable construction. Now, I'll explain this in a minute, but what is trying to say is that when we talk about sustainability, first thing which comes to our mind is, are we losing performance? Are we going to trade off? Are we going to pay for lesser material with a higher cost? Are the consumers cheated? So all these things are kind of something which is called performance. Now the question is, there should be no change in performance and still be sustainable. So what it has to be green, it has to be like well-being, being comfortable, all those things. So those are the two elements of sustainability. At the same time, it has to be economic value and user experience should not suffer. So this is the tug of war which we need to fight and get our products innovated on. And that's the challenge. That's how why things come. Yeah. So as an example, this is a traditional house which we know, which is, if you look at the tall high-rise, it's brick and mortar, it's a heavy construction, it uses a lot of carbon footprint. But today, the world is moving towards light construction. When it's light construction, you can build taller buildings. You can actually have, if it's lighter, the ability to build more is also high. As an example, we have one case where in Hyderabad, which is actually had 9% energy savings in terms of production when we did that. It saves 3,760 tons of material if it had been compared to the original one. And of course, the time reduced as well as an economy. So these are the examples where you can do sustainable solutions, keeping the performance intact. That's the message I wanted to leave that with. So as a summary, my talk to you as the students, as the innovators, as the future technologists, is to understand various aspects of sustainability. It's going to be important that sustainability will be a feature in your work, R&D work, and you have to understand the power of innovation and empowering yourself. That is all about what we are talking about, technology day to day. And you should be able to address this by one element which I want to leave you with. Have the characteristic of inquisitiveness. That helps a lot. Yeah, thank you.
Thank you, sir, for highlighting such an important topic. We hope that in future, more and more people have the equity to work for the sustainable development. Now, I request Director, sir, to present the memento to Dr. Karthik Kumar. Now, inviting on stage Dr. Pushpet Pal Singh, Associate Dean of Research and Development, to conclude the event with his remarks.
Good afternoon, everybody. I understand that I have been invited at a point where you all must be waiting for your lunch. I would like to point out only a few things. We heard the great talks since 9:30 this morning. In order, we started learning from our Honorable Director, Professor Ahuja. He emphasized the importance of fundamentals and moving from fundamentals to innovations. We heard Dr. Naveen Kumar, our Dean Research and Development. He gave you a quick overview of what IIT Roper is doing in the R&D space. We heard a wonderful talk. We learned about what DRDO and what are the capabilities of defense from Sri H.B. Srivastava sir. He is Director General of Technology Management and System Analysis and Modeling at DRDO. We learn about different medical technologies from Dr. Jiten Sharma. We heard Mr. Abhishek Goyal, Vice President and the Global Head of IoT Systems at Infosys. We learned about technologies for good. We learned about that Internet of Things, cyber physical systems, or Internet of Nano Things are bound to come in every space of our life in India, at least by 2030. We heard Dr. Karthik Kumar from St. Govind. He talked about sustainable future. When we talk about sustainable future, of course, we have responsibility from the point we wake up in the morning. We look forward for all your tiny efforts also towards these sustainable goals. A lot of knowledge is available. I only want to put one very non or unknown example of how fundamentals to innovation can bring the world to a very different shape. I do not know if we all know a gentleman called Ascanio Savero. He was the first person who treated glycerol with mixture of nitrate and sulfuric acid. And you know that this particular reaction is highly exothermic. When we talk about highly exothermic reaction, a lot of energy is liberated. But we all know Alfred Nobel. The Nobel Award is given every year for different branches of sciences. So this is the example that I wanted to give you. What Alfred Nobel did is he improved the process, what has been proposed, what had been invented by Ascanio, and he made the entire solution to be fitted in the rocks in terms or in the form of rods, so they can work as what we know today, dynamite. So whatever director in the beginning, Sri Srivastava sir, talked about fundamentals, innovations. This is the probably best example that what knowledge can transform to the great innovation that can change the entire landscape of technology. With this, it's a new age of innovations. We also have some displays and some posters by our PhD students and BTech students. We look forward for the great interaction today, even after lunch. So I don't want to call it a concluding remark. I want to call it Alp Viram. And with this, I thank all the speakers of the session before this. And I thank all of you for being here and being great listeners. So with this, thank you very much once again.
Thank you, sir. On the behalf of IIT Ropar, I would like to extend my heartfelt gratitude to the guests who arrived here and to all the audience for patiently listening all the talks. With this, I hereby take your leave and I request everyone to reach the S. Radhakrishnan block for the project demonstration. Thank you.